Hello everyone, welcome back to this Java learning series. In today's video, we are going to cover one of the most important and powerful concept, that is multithreading. So whether you are beginner or experienced person or brushing up your skill, so this topic is must know for writing efficient and high performing Java application. So let's get started without wasting our time. So first, what is multithreading? Multi-threading is like doing multiple tasks at the same time in programming. So in real life, we will say cooking multiple dishes at the same time. That is multitasking. And multi-threading allows concurrent execution of two or more parts of program. That is called multi-threading. So if you see here example, real life example, suppose imagine you are talking on phone. At the same time, you are writing notes on the notepad, downloading some file, doing some chat, using Instagram, just multiple tasks doing at once. That is called multitasking. And in programmatically, we say that is multi-threading. So that is similar. So in programming, if you say a thread is like a path or line of work your program follows. So with multi-threading, your program create multiple threads. So like loading a file, process data, update UI, this all doing at the same time instead of writing one by one. Okay. So in this way, the advantage of multi-threading is that is better CPU utilization, faster program execution, and that improve performance in the real-time apps. So faster performance, like instead of doing one by one, we are parallelly doing multiple tasks. That would finish early. And how you can achieve threads? This is most important question in interview. So how you can achieve threads? So there are two ways to achieve multi-threading. It by extending thread class and implementing runnable interface. There is two types, extending and implementing runnable. So in program, if you see one program, so here we have created one class that is my thread. That extending thread class, okay, and we are overriding run method. This is our run method present in thread class. So that we are overriding here. So we are following overriding concept and printing just a thread is a main. So here we are creating our main method and creating object of my thread. Creating object of my thread. So and calling our start method. T1 dot start. So start method also present inside thread class. So doing this, we have started our thread. So start in new thread. Okay. So what it will do, it will call internally run method. It will call internally run method and print thread is running. So first our first state is thread started after running. Okay. So run method, the code inside this method will run on the new thread. Okay. And what the start method will do, start a new thread in internally called run method. This is responsible for calling run method. And this is our inbuilt class Java used to create and manage thread. Okay. So in interview also ask by extending thread class with which method you override. What is compulsory to override the method start or run? So just you override run method and call start method. To start method will internally call run method. So what is the thread life cycle? Thread life cycle in real life, suppose like a human stage. First he paused and then started working. sleeping, and dead. This is thread. And similar in thread in programming also goes to same stage. So here, let new thread first, then runnable, running, blocked, and dead. This is the thread life cycle. So in diagram also you can see first our thread will be new. By when we call start method, then our thread will be start. New thread, then start, and then run method will call. That time it will be runnable or running state. And it can be go blocked, waiting, timeout, and terminated. This. So if you see what this life cycle stages doing in simple word, the first is new stage. So what it do? Thread is created but not started. Just a thread created like we did called start method. So thread is created only and that will be new stage but not started. So in real life you can say you plan to do a task but haven't started. That is in new state. And runnable. Second is runnable. So thread is ready to run means started and you are ready and waiting to work. Okay, and running. So thread is actively doing work. So you are actually working on that. That is in running state. After it can be blocked or waiting. So thread is waiting for something, and suppose you are stuck in traffic, waiting for to continue. So that is blocked or waiting. And finally is terminated or dead, you can say. The thread has finished its task, whether successful or failed, whatever. So you completed the task and went home. So that is terminated your task. If you see creating thread example, so this is on extending thread class, implementing runnable interface. And now, what is the thread priority? We have some priority in threads here. So thread priority in Java is a number that tells the system how important a thread is compared to others. So it helps the CPU decide which thread to run first if multiple threads are ready. So but remember this is just a hint, not guarantee. So we have a three priority 1, 5 and 10. So this 5 will be by default normal priority. Okay. So we can like give a priority to thread also. So thread dot min priority equal to 1, thread norm priority equal to 5, thread max priority 10. So 10 is highest priority and 1 is lowest priority here. Okay. And now we will concept synchronization in Java. So synchronization means controlling access to shared resources so that only one thread can use it at the time. So why do we need this? So when multiple threads are trying to access same data, like a bank account, so they can mess things up because it's not handled properly. So without synchronization, what it happens with so one thread might be reading while another is updating. So this cause inconsistent or wrong result. So because of that, we are using synchronization. So how we can achieve synchronization? So synchronized. So synchronized using synchronized keyword, we can achieve it to load a method or block of code. So how? Suppose here we are creating a class counter and creating an increment method and using synchronized with this method. So this method is synchronized method. So what happens to this method is here only one thread can run increment at a time. Multiple will not, only one. Okay. So if you see, we have one inter-thread communication. One more concept is inter-thread communication. What is it? The inter-thread communication means the thread can task each other, usually to coordinate tasks or wait for each other. So why it is needed? So when multiple threads are working together, they may needed to wait for some other to finish something or notify to others when their task is done. So like we have some communication threads methods are there, like wait, notify, notify all. So used for coordination between threads using this. So if you see in executor framework, now we have executor framework. So executor framework, what it do? It is a interface executor framework in Java is a way to manage multiple threads easily. So instead of creating threads manually using new thread, Java provides built-in thread pool using executor. So basically, like using like achieving multi-threading, we use executor instead of creating manually threads. That is the executor framework to handle thread creation, reuse, and shutdown for you. So like no need to do manual things in using executor. So what you do all the way or so like creating object of thread class and calling a start method. So this is our manual creation, thread calling creation. So you manage threads yourself in that. So that is not it's efficient when many tasks needed to run. So this is not efficient to work. That is a headache. So if you use executors, so what to do? We have a executor service. So in executor dot new fixed thread pool. This is a method, thread pool method. Okay. So by doing this, Java handles thread creation and utility use. Java will doing everything. So you can just run hundreds of tasks using just a few threads efficiently. So what here it is doing, we have executor. Okay, executor framework. So that is basically interface with execute method. Okay, and we have executor service that is basically add methods like submit, shutdown. It is a method to add that we'll see next slide. And we have a scheduled executor service. So this basically used to run after delay or repeatedly. Okay, so this is the most efficient way of doing this. So like here if you see this basically creating thread pool of two means two threads parallelly will execute immediately. So what is the advantage of executor? So no need to manually create threads, better performance using thread pool, easy to schedule, submit and cancel the task. So we have like executor service that manage thread pool and we have a submit method that like basically submit a task for execution and we have a shutdown that gracefully stop the executor and as we we have a fixed thread pool that basically creates a pool for a fixed number of thread. So if you see in the program, we are creating a class main and creating our main method and here calling executor service and executors new fixed thread pool of two. Okay. So now here we have to submitted two tasks executor dot submit and task one and task two. Okay. And shut down. So what it do? It has a thread pool of two. So this two task will immediately started. Okay. Suppose suppose we have one more task. We are submitting one more task. So what it will do? Task three. What this will do in this case? So we have a thread fixed thread below 2. So immediately this 2 thread will start it. This third will wait. Once any of this will free, then this will start. Because if we have 3 execute thread pool, then 3 will start in once only. In that case, it will start like this only. So we will executors, Java built-in helper that help for managing threads and new fixed thread pool. So creating two reusable threads here, like we are creating two reusable threads and like why we are doing this. So by doing this, it improves performance and simplifies thread management. So if we see some common problems in this, in multi-threading, we have some common problems. What that can be? So in that we can have like deadlock condition also we can have live lock and we can have thread interface race conditions. This common problems we can have using this. So what it do like live lock what it do? So thread keep changing state. So that in response to each other, but never make progress. Okay. So effect is like a dance, moving but not getting work done. So that can be problem. So by fixing this, add wait, add delay logic for better conflict resolution. So if you can see, two people step side to side to avoid each other, but blocked each other forever. So that is called. And if you see deadlock condition, the two thread waiting for each other. That is called deadlock condition. So in interview also ask you what is deadlock. So deadlock means two or more threads are waiting for each other. Like all are waiting for each other and blocked. So program will hang. So fixing this nested lock always acquire lock in some orders. For example, if thread A hold lock 1 and waiting for lock 2 and thread B hold lock 2 and waiting for lock 1. So both threads are stuck there. So that is called deadlock scenario. And starvation is like a thread wait too long and never get CPU time. So effect what will affect? So one thread may never run while other keep running. So how we can fix this? So like use fair locking or proper thread priority. Like we have some thread priority notify, join, sleep, post. This we can use. So a low priority thread is always pushed aside by high priority one. So that is the case. And if you see like one more is the race condition that like two or more threads access and change the same data at the same time. That is called race condition. So this can be common problem that we can be resolved by using the methods. We have predefined method using that we can prevent. So like best practice for this, use executor framework instead of thread and avoid thread mutable state and you synchronize wisely. So that's of our view of multi-threading. So see you in next video. Don't forget like, share and subscribe. Thank you.